Hope you guys are all doing well. In this video, we'll be looking at applying systems of linear equations. So we've been working on solving them by graphing, substitution, and elimination. Now we're going to be looking at word problems where we've got two variables that we need to solve for at the same time. So when we are applying systems of equations, it's very important to remember to define your variables and analyze the solution. So in previous problems when we've been graphing substitution elimination, we've just gotten an answer of x and y. That was the ordered pair, that was the intersection point if I was looking at their graph. Here, when we're looking at systems and we're looking at their applications, those variables represent something. So we got to know what those variables are talking about and then what their numbers, what their solution, what that actually means. Okay, so we got a couple of examples. Example A, we've got at a restaurant, 3 tacos and 2 burritos cost $23.35. A second order of 4 tacos and 3 burritos costs $33.40. So we got to define our variables. Hopefully we should be able to recognize that we're looking for tacos and burritos. Those are the two things that we're dealing with here. Okay, so when I'm dealing with tacos and burritos, let's define our variables that way. So I'm going to call T is the price per taco and B is the price per burrito. Okay, so if I start to write this out, define your variables. T equals the cost per taco and B equals the cost per burrito. Okay, so I'm going to highlight some key information here. We're given this information right here. 3 tacos, 2 burritos cost $23.35. So what is that equation going to look like if I've got these two variables t and b? It's going to look like 3t plus 2b equals $23.35. Because I take the cost per taco and I multiply it by 3. Take the cost per burrito, I multiply it by 2. So I've got how much I spent on tacos and burritos. If I add those together, I know the total is $23.35. Similarly, we've got this second order here. 4 tacos, so 4t, plus 3 burritos, 3b, equals $33.40. We've got a system here now. So now we can solve for both t and b. I'm going to solve for t first. I'm going to do elimination since they're both in standard form. So what do 3 and 4 both go into? Those both go into 12. 3 and 4 both go into 12. So I'm going to multiply the top equation by 4. And the bottom equation I'm going to multiply by -3 so that they're opposites of each other. So the top equation is going to become 4t plus 8b. I'm going to use my calculator here, 23.35 times 4, 93.4. And the bottom equation is going to become, what did I do? Hang up a second. You probably caught this. It should be 12t. 12t plus 8b equals 93.4. For some reason, I forgot to actually multiply those two numbers. The bottom equation is going to become -12t minus 9b equals -3 times 33.4, -100.2. So now these are ready to be eliminated. The t's are. So the t's are gone. 8b minus 9b is -b. And 93.4 minus 100.2 is going to give me -6.8. So b is equal to 6.8. So now we need to plug that back into either the top or the bottom in order to solve for the other variable. So if I plug it into the top, I've got, I'll go back to the original color, 3t plus 2b, but instead of b, I can substitute 6.8, equals 23.35. So that's going to be, after I start to simplify this, 3t, 2 times 6.8 is going to give me 13.6. So 3t plus 13.6 equals 23.35. I'm going to subtract 13.6 from both sides. And I'll get 3t equals 9.75. Divide by 3. T equals 3.25. So we've got these two answers here. I can plug it back into the second equation just to make sure I did it right. So if I plug 3.25 in for t and 6.8 in for b, you'll check that the left-hand side equals 33.4. So this is my solution. Normally we'd be done here. But remember, we got to analyze this. What do these numbers mean? All right, so if I wanted to analyze this solution, I'd be able to say that a taco costs $3.25 and a burrito costs $6.80. So that's what I can find here. You can find those individual prices. So then this follow-up question says, how much would it cost? So we got a new order here. We got 5 tacos and 1 burrito. All right, so I'm basically finding what is 5t plus b. So I got 5 times 6.8. Oh, sorry, hang on. That's not t. T is 3.25 plus b, and that's where it's 6.8. So if I simplify this using my calculator, I would get $23.05. So it would cost $23.05. My 3's are off on this app. All right, so that's how we can use an application, or how we can do an application problem. Define the variables, set up your system, solve it normally, analyze what those numbers mean, and then now we can use those numbers to answer further questions. Okay? Let's go on to the next one. You are planning a dinner reception for a family reunion. A banquet hall in McHenry charges $15 to rent and $12 per guest for food and drinks. A banquet hall in Crystal Lake charges $180 to rent the hall and only $10 per guest. All right, I think this is a typo. This is supposed to say 150, if I remember correctly. All right, so we got 2 variables here. We've got $150 to rent the hall if we're in McHenry, or $180 to rent the hall if we're in Crystal Lake. Those are flat fees. That's not going to change depending on how long we're spending at the banquet hall. So those are our starting places. Okay? Now, the $12 per guest for food and drinks at McHenry or $10 per guest for food and drinks at Crystal Lake, those are reoccurring fees. So these 2 equations are going to be in slope-intercept form because we got a one-time fee just to rent the hall and then a reoccurring fee depending on the number of guests that we have. So my variables, x is going to be the number of guests, and y is going to equal the total cost. So for McHenry, this equation is going to be y equals 150 just to rent the hall plus $12 per guest. So 150 just to rent, $12 per guest plus 12x. For Crystal Lake, that total cost is going to be $180 just to rent the hall plus $10 per guest. So the question is asking For how many guests, so we're solving for x, how many guests will the charges be the same? So we see this word same. In math, that means equals. So this is basically asking us, when will the costs be equal to each other? So when will the y's be equal? So this is going to be substitution. If I take this and I substitute it in for y here, we can solve for x. So we get 150 plus 12x equals 180 plus 10x. Subtract 10 from both sides, so I get, 10x. Get our x's on one side, numbers on the other. So 150 plus 2x equals 180. Subtract 150 from both sides. I'll get 2x equals 30. Divided by 2, x equals 15. So for how many guests will the charges be the same? For 15 guests, you'll be charged the same amount at either banquet hall. Okay? And we can check, what is that amount? Well, 150 plus 12 times 15. If I plugged 15 in for x, McHenry would charge me $330. Crystal Lake better charge me the same, since that's what this question's asking, and they do. All right, so for 15 guests, you'll be charged the same amount. So that one's a little tricky because it's in slope-intercept form instead of standard form. All right, so we got one more example that I'll do for you. Part C. We got a company, Red and Yellow, making a mixture of regular and peanut butter M&Ms. The regular M&Ms cost $3 per pound. The peanut butter M&Ms cost $5 per pound. 50 pounds of the mixture costs $194. So this one gives students difficulty across the board. All right, so first off, we always want to start, what are our variables? So we've got regular M&Ms and we've got peanut butter M&Ms. So I'm going to say R represents the number of pounds of regular M&Ms in the mixture. And I'm going to say P represents the number of pounds of peanut butter M&Ms in the mixture. So those are our two variables. So we've got regular and peanut butter. We've got something that deals with their money. Regular costs $3 per pound. Peanut butter costs $5 per pound. So we've got a total here that deals with money. So I'm going to highlight everything that deals with money. So that's going to be my first equation. I can do 3R plus 5P equals $194. This deals with the money. All right, 3R plus 5P equals 194. So what number in this problem have we not dealt with yet? Oops, we haven't dealt with this 50 pounds. This 50 pounds. So that's a total, but it doesn't deal with money. It just deals with how many pounds of mixture there are. Okay? Remember, what's in this mixture? This mixture is comprised of regular M&Ms, which is R, and peanut butter M&Ms, which is P. So if I take the pounds of regular M&Ms, which is R, and the number of pounds of peanut butter M&Ms, which is P, if I add those two together, that's going to equal the total pounds in the mixture. So this equation right here deals with the total pounds. Something that might help if I label these pounds of regular, P represents pounds of peanut butter, and 50 represents total pounds. So this second equation, that R plus P equals 50, that's the one that gives students the most difficulty. You're usually able to set up the money one, because that's just like the tacos and burritos problem. So you're usually able to set up that standard form, 3R plus 5P equals 194. It's this second one that gives students difficulty. So now that we've got a system, part B asks us to find how many pounds of peanut butter M&Ms were in the mixture. How many pounds of peanut butter M&Ms? So we need to solve for P. So if we're going to solve for P, we might as well eliminate the R's. So we have 3R and R. So I'm going to make this bottom equation. I'm going to multiply it by -3 so that the top equation can stay the same. 3R plus 5P equals 194. And the bottom equation is going to become -3R minus 3P equals -150. All right. The reason I did that is so that I could eliminate the R's and solve for P, because that's what we're looking for. So if I add these together, the R's are gone. 5P minus 3P is 2P. 194 minus 150 is 44. Divide both sides by P. Divide both sides by 2. P equals 22. Got a little ahead of myself there. So how many pounds of peanut butter M&Ms were used? 22 pounds of peanut butter M&Ms were used in the mixture. It doesn't ask us to solve for R, so I'm not going to do that. I don't have to plug that 22 back in. We can if we want, but we don't need to, because all it asks us was how many pounds of peanut butter M&Ms were in the mixture. Okay? So, applications, once you set up your system, you just solve using substitution, elimination, or graphing, just like we have been. The difficulty now is being able to take the numbers out of the word problem and write those equations, set up that system. So I got 2 problems here for practice. Pause the video now and try those out, and I will throw up the answers. All right, make sure you've paused and tried them. Here are the answers to this practice problem, these 2 practice problems. So you'll see number 1 is like the tacos and burritos problem, and number 2 is like that peanut butter M&M problem. So make sure you understand how to work both of these. If you have any questions, let me know. All right, this is the last video of this. This is the last video of this unit. So we're ready to wrap up this unit and start testing on it. So make sure if you have any questions on solving systems or these applications, you let me know. Have a good one. I'll see you when I see you.